Hi, so today we're going to be going over a board for somebody who took the class. His name is Michael. He said that it heats up a lot. So this is an 820-3115 board. And let's try to figure out what it is that's heating up. Let's try to get an idea of what's going on with it and see if we can help him out and see if this is something that is savable or something that's hopelessly fucked. So the first thing I'm going to do here is I'm going to plug it into a charger. So let me just get a working DC-in board, which it looks like I don't have here. Aha, of course I have it here. Okay, I can't wait to get my office back. So today I'm going to be moving everything back to my office because in 2 days my staff will be back and they will get to have fun. Because after all this, I am definitely going on a well-needed... Who am I kidding? No vacation for me. I'm going on well-needed more work. All right, so let's see. So if I plug this thing in, okay, I get a green light in the charger. So the first thing I'm going to start doing here is I'm going to measure the voltage rails. I want to see what is present, what is not present, and go from there. So the first voltage rail that I'm going to measure on this machine to see what's going on with it is PP bus G3 hot. That's the most important rail, and let's see what I get over there. So I get 1.56 volts, also going around to 1.7. Of course, you can't see that because the multimeter is hiding. So yeah, let's see. I get 1. Yeah, like it's going 1.5, 1.4, 1.6, and that's what happens when the charger is limiting power, ow, fucker, because of a short circuit. So I just went to touch the board. I just went to touch the board right now, and something burned me. Now, I mean, this should kind of give you an idea of what's going on. So again, before I even go to detect a short circuit, I understand that something is shorting at the ground, and I understand that what's shorting at the ground may be the stuff that's on the corner of the board because it just burned my finger when I went to touch the board and move it over so that I could start measuring it. So I'm going to open up a schematic for the 820-3115 motherboard. I remember when this was new, but this is actually like starting to become a piece of shit just because it's, you know, it's fucking Ivy Bridge, and the computer's this computer has a lower screen resolution than my phone. You know, it's a piece of shit now. So I mean, this is a board that it goes to a computer that is, again, this machine still sells for like $700, and that's the thing with Apple. Their stuff holds value even after the specifications long make it a piece of crap. So PP bus G3 hot is not where it's supposed to be, right? And the part of the board that burned me is right up here. These caps. So C3897, C3896. When we look at these capacitors under the microscope, let's just take a look at that area that burned me. Let's get a good view of it so that I can show you what's going on. Let's see. All right. So I mean, you should have an idea of what the problem is here, because I mean, look at that. So those capacitors don't really look very nice. Now, this is a classic case of the T29 boost circuit for thunderbolt, shorting and DisplayPort and all that good stuff, shorting PP bus G3 hot to ground. So let's go back over to the schematic over here. So C3897. I miss 4K. God, I miss 4K. All right, so this over here, these capacitors are burning, absolutely burning. And remember, the T29 boost circuit comes about from the PPV-in T29 boost. So this comes from PP bus G3 hot. See, this PP bus G3 hot is the first rail over here. It's the first rail. I checked that after I checked the PP3V42 rail. I know that the PP3V42 rail is there because my one-wire circuit is working. So what I'm going to try to do now is I'm going to try to get rid of that short to ground and see if removing those capacitors that are burning my fingers do the job. So again, PP bus G3 hot is being shorted to ground. The capacitors that burn me are on along something that's around this power rail, and that power rail is actually PP bus G3 hot. So PP bus G3 hot feeds the T29 boost regulator, and the output of the T29 boost regulator is actually burning my finger. So what I'm going to do over here is I'm going to remove those disgusting looking capacitors that just burned me. Again, I'm not going to really measure anymore. I'm not going to inject power to see if there's a short there because the little mark that it's on my finger right now is proof enough for me that that's the problem. And you're going to see this very often on these boards. Mainly because they have all this circuitry right on the edge, and the edge has absolutely no protection from water. Not a single thing is done here to keep liquid from getting in the machine. Again, these Apple products, they are not designed like the IBM ThinkPads. They're not designed like the Lenovo ThinkPads. They're not designed with any real idea towards longevity or durability. They're just designed to look pretty and have pretty software and have a pretty interface and to be thin, but no real thought goes into what's going to like how is this going to get used in the real world? Are people are they going to be sitting in coffee shops where people will spill coffee on a table? Should we make it so that the part that's absorbing it is right next to where the water is most likely going to spill on the side? Again, it's, are we going to make this product so that when something is spilled, it's resistant a little to it? Or are we going to make this product so that when something is spilled, it actively gets shot into the highest voltage part of the machine and fucks it? This is one of the subtle differences between a ThinkPad and a MacBook. And again, a big part of it is just, this stuff. There's no thought put to any of these things. It's all about making it look good. It's all about nice interface. It's all about nice looking design. But when it actually comes to things like long-term durability, you are not going to find that Apple gives a shit. And the thing is, there's absolutely no reason for them to give a shit, because we have collectively shown them as customers that we will continue to buy their products regardless of the lack of durability, regardless of the lack of upgradability. That, again, it doesn't matter. Like, people always complain. They say, the MacBook Air doesn't have user-upgradable RAM, and it doesn't use a standard M2 SSD, and it doesn't use this, and blah, blah, blah. And it's like, okay, then stop buying it. Or the iPod doesn't have a removable battery. Okay, then stop buying it. But you keep buying it. Like, all the same people who complain about all these features, they complain about all this shit left and right, but do you actually have it in you to stop buying the product that has these limitations that you don't like? See, I think Apple has a lot of great things about their products, but there are also things that I don't like about their product. And because I don't like those things about their product, I will simply not buy them. But you guys, I notice a lot of the people who really complain hardcore about all this, you're the same people very often that will actually buy this shit. And it just doesn't make sense. Because, like, again, what motivation what are you giving them to not to change? You're not giving them any motivation to change. So as you can see, PP Bus G3 Hot has to be back because the fan is spinning. Since the fan is spinning, I know PP Bus G3 Hot is back. So what I'm going to do over here under the microscope is I'm going to replace those fucked capacitors with new ones so that we have a properly working T29 boost circuit. Again, now, also, you have to keep in mind that there are times when you're not going to have a working T29 boost circuit. Sometimes there are three levels of Thunderbolt failure here. The first level of Thunderbolt failure is something really, really basic like this, where it's just like a few components, a few capacitors, or two pieces that short it to ground in a very relatively superficial fashion. And what I mean by superficial fashion is that there's no hole in the motherboard. It's not like this thing is totally destroyed. It's not, you don't notice a lot of issue with it. It's like the board is really, like, the PC board looks good, the surrounding components look good. It's just a few components that just so happen to have gotten hurt. The second level is when you have a couple of burnt pads here and there and a couple of really destroyed components around it. That's not great, but then you can still fix it. The third level of failure is when you'll see that there's holes in the motherboard. You actually have holes in the motherboard, and at that point, what I do is I cut out the T29 boost circuit as if it were an appendix, and I've talked about this before. When that circuit is really destroyed, you actually risk ruining PP Bus G3 Hot from ever working again by trying to fix it. So again, in those situations, what I do is I cut the trace on the boards that leads to anything relating to T29, and I cut the traces. I cut so that nothing is going to be traveling there, and then I remove all the components after it, just as a precaution. But this is a case where it's clearly okay to restore Thunderbolt. We'll be just fine. Man. Aw, now I mixed that capacitor up with the bad ones. Mofo. All right. I have a bunch of 820 3115 boards, so no harm, no foul here. They're just not organized as nicely in this box here as they were when they were in the separate boxes for the different types of boards in my office. But I'll find it. And of course, most of them are actually missing those pieces because that's a very, very common thing to go bad. Since it's very common, I use it often. Here we go. Fresh donor boards from David. Let me unpack these. These should have those pieces on them. Jesus. These boards have all been just destroyed. They have nothing useful on them anymore. I couldn't. If I sold these boards for $5 on eBay, $5, I would find myself with PayPal claims. Like these boards are legitimately not worth $5 anymore. I mean, they're just bleh. Everything is missing. Jeez, it's like we're pillagers at this store. Okay. Okay, let's get this. My soldering, as usual, is shit. So let's see if we can make that look a little bit better through the magic of Amtech 559. And curvy tip. So let's get curvy tip here up to a good point, a good 840 degrees. Come on, there we go. Look better. Looking better. Looking better. See what it does? Good flux. Good stuff. All right. Okay. That's good. Now what I want to see here is I'm going to unplug my monitor and I'm going to hope that that doesn't ruin my recording here or freeze anything on my system. And I'm going to use that plug with this. First I got to put a RAM stick in it. So let's get a RAM stick here. Oh, who am I kidding? I have a bin of DDR2 here. We really are sodomizers. Everything is... Jesus Christ, it's all gone. Where can I find some RAM? I miss my office. I can't wait to go back to my office. I'm excited. Literally, like one day. That's all we have. Right? Here we go. Lewis's liquid fucked computer. So we're going to put a little RAM stick in there. And I touched the flux part of the... disgusting. I'm going to wash that off with soap in a second. And wiping it off with alcohol is really not the right way to do this. Anyway, let's see. We're going to... Okay, we unplug my monitor. And plug you in here. And so I know that it turns on. Let's see if I get display port. Because if I get display port, then both issues are fixed and I'm good. So let's pay attention to the screen over here. And let's see what happens when it turns on. Does it... Come on. You're my only monitor attached. Okay, here we go. So it turned gray. It's a good sign. All I'm waiting for now is a question mark folder. Once I get the question mark folder, I'll know that I'm good and that I'm set and that this is ready to go back. Question mark folder, mofo. Come on, you piece. I'm so impatient. He's impatient too. You see that guy, jackass in the left monitor over there? Okay, I see a world icon. Whatever, same shit. That's a picture. Good enough for me. You're good to go. All right, so let's plug this monitor back in so that we can go over a little bit of what was going on here and also go over what it is you missed so that you won't miss it next time. Alrighty, so remember in class when we were doing that whole thing with finding a short to ground, and remember when we were checking the power rails? So the first thing that you would do here on this schematic here is you're going to check for power rails. Come on, wireless piece of crap keyboard. There we go. K330 with new batteries. You are literally like 2 feet away from the computer, and sometimes you don't work. Love it. Now we see we go to the power rails page here. Now this lists every power rail on the computer. So you should plug it in and see what it is that's missing. So over here, PP bus G3 hot was the one that was missing. Now if you want to find where PP bus G3 hot is in the computer, you can go over to the board view software, type N, and then type in the name of the power rail, PP bus underscore G3 hot, and then it's going to show you everywhere on the board that that power rail shows up. So you can measure anywhere. And my favorite place to measure for it is on the big white fuse right next to the RAM slot, which is F7040. Now, what I did at that point is I just had the multimeter in voltage mode, which meant that I take the... Oh, I can't wait to go back to my office. Fuck this shit. Anyway, so I take the black probe over here and I put it on ground. On this board, ground is going to be a screw hole, so any one of these things on the side. And then I take the red probe and I put it over there. And then I read the value that I get. Now, the value that I get is supposed to be 12.6. So again, if we go back to the schematic over here, you'll see it says voltage, well, 12.8. So most of the time it's 12.6, and that's really realistically what you're going to see on your multimeter. So it says 12.8. And what I got was 1.5. Now, at that point, one of the first things that you're going to want to do is unplug power from the board, take your multimeter, and put it into either ohm mode, diode mode, resistance mode, whatever it is you have. I take usually red probe on ground, and black probe on here. If you're doing resistance mode measurements, it doesn't matter. If you're doing diode mode measurements, it's best to keep the red probe on ground for the specific measurement. So I take that and I put it on ground, and I take the other probe and I put it on where the power rail is. When what I'm doing here is I'm trying to measure the resistance to ground. Now, if the resistance to ground is really, really low, that means that there's a component somewhere along this board that's sending all of its power to ground. So right now I have, 15 million ohms and counting, which is not a short to ground. Now before, again, I didn't actually measure using the multimeter to see if I had a short to ground. I knew that I had a short to ground because something was getting really, really hot. Now the way this works is if any one of the components on this line is shorted to ground, all the power is going to go to ground instead of going on another part of the computer. So if we go over to F7040 over here, here we go. So this is where I was measuring right here. Come on, here we go. So let's say this capacitor over here, see this? It's going to ground. Now let's say it's shorted to ground. Let's say this capacitor has become a wire. Instead of only passing the AC component to ground, it's going to be passing everything to ground. And if this capacitor is passing everything to ground, what's going to happen is that all this power here is going to be going to ground through this component instead of going to wherever it's supposed to. Now, this capacitor over here is not meant to pass a lot of power. It's meant to pass the tiny, tiny little bits of AC that may be present there. It's not meant to actually pass the entire signal to ground. So what happens when you put a lot more power through something than you're supposed to? So let's say you take a little speaker and you hook it up to a 500-watt amplifier, like a tiny little speaker like these PC speakers. Let's say I hook them up to the power sound amp in my office and I turn them all the way up. The voice coil inside the speaker is going to get really hot because it's not meant for that level of power, and then it's going to melt or explode. And the same thing is true over here. That little capacitor is going to get really, really hot. It's because it's not meant to have that much energy going through it. It's going to burn. So it's going to be really hot, and you're going to feel that. And then when you feel that, you're going to want to remove the components that get really hot. Now, sometimes they don't get really hot. Sometimes when there's a short to ground, the power rail will actually not work at all. In this case, what happens is the protection circuitry limits the charger to 1.7 volts. In your case, it was 1.5 for some strange reason. Usually it's 1.7. And it's going to limit the power. So you actually didn't even have to inject voltage to find out what the hot component was. If you have a short to ground and you notice that nothing is getting hot with the charger plugged in, as will happen in most cases, you'll take a bench power supply, and what you want to do is you want to inject 1 volt into that line. So when I say inject 1 volt, what I mean is you take the ground of the power supply and you'll solder it to a screw hole or a ground terminal on the motherboard, and then you'll take the positive terminal of your power supply and you'll put it on the power rail that's missing. Now, I like to start at 1 volt. The reason I like to start at 1 volt, what if the FET for CPU circuitry is what's shorted? And that short is going to the CPU. So if I say this is a 12-volt power line, let me just put 12 volts in there, and the component that's shorted is a component that's supposed to make pulses for the CPU, I'm going to send 12 volts directly to my CPU and I'm going to kill it. Or if the FET for the GPU is bad, I'm going to send 12 volts to my GPU and I'm going to kill it. You know what I mean? So I like to start this at 1 volt and then slowly raise it up based on whether or not I am not able to find where the short is. Again, I don't bother with current limiting. Make sure the power supply is set to deliver the maximum amount of current possible. Always have the power supply set, like turn the current all the way up. But you're going to limit the current by limiting the voltage. So you want the current turned all the way up on your bench power supply, no current limiting, but start out at like 0.5 volts and then see if something gets hot. Then go to 0.6 volts, 0.7 volts, 0.8 volts, and you'll eventually find something that gets hot. So again, if you didn't burn yourself on the board like I just did, what you could do is you could attach this power supply to the board in the manner in which I showed you, the ground going to the screw hole, the positive terminal going on the power rail that's shorted, and then go over the board and see what gets hot, and slowly raise the voltage based on what it is you see that's going on. And that's pretty much what you're going to do, and you would have found out that those capacitors were boiling hot. You take them off, and you replace them with other ones. You make sure everything works afterwards. You make sure the short is gone, and you're good to go. So that's pretty much that, and I hope you learned something.